Given enough time and energy, the body will heal, but when doctors or engineers intervene, the processes do not always proceed as planned because chemicals that control and facilitate the healing process are missing. Now, an international team of engineers is bioprinting bone along with 2 growth factor encoding genes that help incorporate the cells and heal defects in the skulls of rats. Growth factors are essential for cell growth, said Ibrahim T. Ozbolat, Associate Professor of Engineering Science and Mechanics. We use 2 different genes encoding 2 different growth factors. These growth factors help stem cells to migrate into the defect area and then help the progenitor cells to convert into bone. The researchers used gene encoding PDGF-B, platelet-derived growth factor, which encourages cells to multiply and to migrate, and gene encoding BMP2, bone morphogenic PR. They delivered both genes using bioprinting. We used a controlled co-delivery release of plasmids from a gene-activated matrix to promote bone repair, the researchers stated in the journal Biomaterials. The 2 genes were printed during surgery onto a hole in the skull of a rat using a device very similar to an inkjet printer. The mixture was created to release a burst of PDGF-B encoding gene in 10 days and a continuing release of BMP2 encoding gene for 5 weeks. The rats that received bioprinted genes with controlled release of BMP2 encoding gene saw about 40% bone tissue creation and 90% bone coverage in 6 weeks compared to 10% new bone tissue and 25% bone coverage for rats with the same defect, but no treatment. This method is better than simply dumping the growth factors, said Ozbolat. If we do that, the amounts of proteins are finite, but if we use gene therapy, the cells continue to produce the necessary growth factors. Working with Ozbolat from Penn State were Kazim K. Monkal, graduate student in engineering science and mechanics, Gregory S. Lewis, assistant professor, and H.W. Others contributing to the research include R. Seda Tilly Aydin, former Penn State postdoctoral fellow now at Bülent Ecevit University, Turkey; Dong N. Heo, former Penn State postdoctoral fellow now at the Kyung-hee University, South Korea; and Timothy M. Akri, former graduate researcher, and Aliaski. The International Team for Implantology, the National Institutes of Health, the National Science Foundation, the Osteology Foundation and the Scientific and Technological Research Council of Turkey supported this work. Make a difference. Sponsored opportunity. Story source. Materials provided by Penn State. Original written by Audrea Elise Messer. Note: content may be edited for style and length. Controlled co-delivery of PDGF-B and PBMP2 from intraoperatively bioprinted bone constructs improves the repair of calvarial defects in rats. Biomaterials, 2022. 281–121333 doi. 10. 1016 J. Biomaterials. 2021. 121333. Cite this page. Penn State. https://ift. tt. rcwzxkg. Accessed April 12, 2022. Thanks for watching. Please subscribe my channel for more videos.